Hey guys, Mr. Burns here. We're working on page 266, number 11. What the instructions say is we're going to complete each of the following. We're going to do A, graph each function by making a table of values. B, determine the consecutive integer values of x between which each real zero is located, and estimate the x coordinates at which the relative maxima or minima occur. Okay, and I'm working on number 11, so my f of x is equal to a negative x cubed plus 2x squared minus 4. Okay, and you can see I've already filled out my table of values. These are my x values, these are my f of x. The way that I build this table is that I'm plugging in each individual x value into this equation to get their f of x or their y value. Okay, that way I'll be able to graph these. Key things when you're doing this, make sure that you're using order of operations and function notation to make sure that you get it. So if I was going to find f of negative 4 for you, that is equal to the negative 4 cubed plus 2 times negative 4 squared minus 4. So negative 4 cubed is negative 64, but that's times a negative 1, so that's going to be 64. Negative 4 squared is 16 times 2 is 32. And then negative 4 drops down, so 64 plus 32 is 96. Minus 4 is how I get 92 here. Okay, so this will be your answers for A. The way that you select your x values, a good way to go is go from negative 4 to positive 4. Also, you can minimize that based upon your leading degree. Remember, degree corresponds to how many real zeros this could possibly have. Doesn't mean that it's going to have exactly 3. It means that it could have at most 3. Okay, and how many I have is determined by this interior stuff. But negative 4 to 4 is a good value. It's about 10 numbers. Most of the zeros will appear closer to the x-axis or to the y-axis or the origin. So we should have a good amount of information to answer our questions. So this would be your answer for A. Once again, I plugged in all of my x values to get my f of x or my y values. Okay, so now we're going to move on to B. B says determine the consecutive integer values of x between which each real zero is located. So I'm looking for real zeros. The good thing is a polynomial function is continuous, and based upon the location principle, I'm going to be looking for sign changes of my y values. So you can see I'm at a positive 92, positive 41, positive 12, and then I drop to a negative 1. What that means is that I've had to have crossed the x-axis. Remember, the x-axis is where at which y is equal to 0. So if I go to from a positive to a negative, or from a negative to a positive, that means somewhere in here there's a real 0. So our first one is between negative 2 and negative 1. Okay, now I've switched to negative. I stay negative, I stay negative, I stay negative, stay negative, I stay negative. So the real zeros are between negative 2 and negative 1. Okay, and now let's look at C. This says estimate the x-coordinates at which the relative maxima or minima occur. Well, once again, for this type of problem, I'm going to be focused on my y values, but rather than looking for sign changes between y values, I'm going to be looking for maximum values, or where I'm increasing and then I stop and I start to decrease again. So if I'm looking, I go from 92 to 41 to 12 to negative 1. So I'm decreasing all the way through that. Negative 1 to negative 4, I'm decreasing. But then you can see I go from negative 4 to negative 3, so I increase. I increase here. So that means I'm going to have a relative min at 0. And that's because when I plug in 0, I get a -4. When I plug in -1, I'm at -1, and then I'm at -3. So this is really a minimum value. Okay, and now as I'm looking, I go from -4 to -3 to -4. So -3 is bigger than -4. So that means that this is a relative max. And that is problem number 11 on page 266.